Hi, Addy. Welcome to lesson number 33. And this lesson is going to be awesome. I'm really excited for it because we're going to learn about exponents, which is super fun. And then we're going to learn how to write decimal numbers as fractions, which you already know a little bit about that. So that part is going to be pretty easy for you. But the first thing that we're going to do is your facts practice. So get out your facts practice. It is 24 mixed numbers to write as improper fractions. Okay, so get that out. I'm going to get out a clock for you. Make sure you have a pencil. I'm going to find some music for you. And on your mark, get set, go. You have 5 minutes. Keep going, Addy. You're doing awesome. All right, we're gonna stop it right there. Okay, I was really enjoying that music. Hopefully you liked it as well. It wasn't too distracting. Anyway, all right, let's jump right into this lesson. This is lesson number 73. First of all, why don't cannibals eat clowns? Because they taste funny. That's a scary clown actually in that picture. And it's about cannibals. That's a little bit of dark humor, but maybe, okay, we'll just move on from that one. Let's jump into mental math, okay? So for mental math, we are gonna count up and down by 25s, between 25 and 300. Whew, all right, let's see if we can do it. We're gonna start with 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300. All right, now we'll count down. Tell me if I make a mistake, okay? We're gonna do 300, 275, 250, 225, 200, 175, 150, 125, 100, 75, 50, and 25. We did it! Woohoo! All right, and that little bunny danced along with us. All right, let's go into the rest of your mental math. We're gonna start with 4 times 112. See if you can do that. And these GIFs are just like random GIFs today that I thought were a little entertaining. For B, bring it. We're going to do this. It's 475 minus 150. Maybe it helps if I do something like this, huh? That would help me. I don't know. All right, for C, it's going to be 4 times 99 cents. I would do 4 times $1 and then realize that I multiplied too much, so I would subtract 4 cents from that. Okay, what about this one? $2.99 plus $1.99. What if we make this $3 and we make this $2? And then we subtract 2 pennies from that, huh? All right, this is the most patient dog in the world. We're gonna double $3.50. 350 times 2. All right, and then we're gonna do 350 divided by 10. What do you do with that decimal? All right, and this pigeon's gonna walk along with us while we do this long problem with a lot of 3s. We're gonna do 3 times 3, then multiply by 3, then add 3, now divide by 3, subtract 3, multiply by 3. What do you get? Okay, the next thing we're going to do, I didn't write it down, but you're going to hold your hands 1 yard apart and then 1 meter apart. Does it get bigger or smaller? You're going to go from 1 yard to 1 meter. I know there's 3 feet in a yard, and a meter is going to be bigger than that. All right, let's go to problem solving, and hopefully this is not the look on your face when you see this problem. But they basically just describe the steps from the fraction chart that would be used to find the answer to this problem. So remember your fraction chart, and here we're doing addition. So do we have to find common denominators? Yes, we do. Whenever you're adding or subtracting, you have to find common denominators. So we're going to find the least common multiple right here and change this to something over probably 12, huh? And this one to something over 12. Then we're going to add, and then it basically just says to describe the steps rather than doing it, which is weird because if you do it, then you know the steps. So you can either do it or you can write the steps. but remember the shops rule. You have to shape it, get the common denominator, then you have to do the operation, operate, and then you have to simplify. Okay. All right, this is brand new information right here. Here we go. We're going to talk about exponents. Now, since lesson 38, we've used the exponent of 2 to indicate that a number is multiplied by itself. So that means 5 squared is equal to, what is it? 5 times 5, because you multiply it by itself. So 5 times 5, and you get 25. Okay? What about 5 cubed? This is going to be 5 times 5 times 5. This number tells you how many times you have to multiply 5 by itself. This is called the base. I'm going to write that down, base. And this is called the power. Power. So it's like a power of 3. You multiply the base by the power of 3 in that situation. What about the one under it? 5 exponent 4 means 5 times 5 times 5 times 5. 4 times. You multiply this base 4 times. Okay. Now, there are ways that you describe it or the way you say it. So this is how you say it. When you see something like this, 5 with the little exponent of 2, you can say 5 to the second power, or you can say 5 squared. And that's what it means. And squared means, like, if you have a square, literally have a square, and one side is 5 and the other side is 5, the area is going to be 5 squared, which is 25. So that's why it's called squared. So that's pretty cool, huh? Now, what if it's this? How do you say this? You can say it 10 to the third power, or you can say 10 cubed. Just like we had a square before, instead of a square, this time you have a cube. And, whoops, I didn't draw that very well. But anyway, 10 cubed. And it turns out that the volume, the way you solve for the volume, is 10 times 10 times 10, so 10 cubed. That's assuming that each length on that square is 10. So it's 10 to the third power or 10 cubed. So there are different ways to say it. This is, right here, 3 to the fourth power. This one is 2 to the fifth power. And this girl is saying, Addy is so smart because you're following along and doing this lesson. And this lesson is pretty tricky, so good job. All right, we're going to jump into example 1. Let's go. Yeah. All right, so they want us to compare this number and this number. And which one's bigger? Is it going to be equal? Is it going to be greater than, less than, whatever? We're going to put the right symbol in there. So we have to figure out what each one means. The first one is 3 raised to the fourth power, and that means 3 times 3 times 3 times 3, because there are 4 3s, okay? And the next one is 4 to the third power. So this is actually going to be 4 times 4 times 4. So let's figure out this first one. 3 to the fourth power. 3 to the fourth power is 3 times 3 times 3 times 3. What does that equal? Well, 3 times 3 is 9. Times another 3, you have 27. Times another 3. Oh, actually, you know what you can do that's even easier than that? You can do 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So that's what this all is. This 3 times 3 times 3 times 3, or 3 to the fourth power, is the same as 81. Okay, what about this one? 4 times 4 times 4. Well, you have 4 times 4, which is 16, times another 4. It turns out to be 64. So which one's bigger, 81 or 64? All right, so the thing that goes here is that greater than sign, because 3 to the fourth is definitely bigger, which is interesting, right? Because the base is only 3 and this base is 4. So that's interesting to know. Once you start putting exponents on things, those numbers grow very rapidly. All right, let's do example 2. This guy's saying, bring it. Give me some more. It says, write the prime factorization of 1,000 using exponents to group factors. Okay, so that sounds pretty complicated. So let's start with step 1. Write the prime factorization of 1,000. And we can do that no problemo because we are used to doing that. So we're going to start with 1,000. 1,000 is what? Like 100 times 10, right? And 10 is 2 times 5. So we're down to the prime numbers there. What about 100? 100 is 10 times 10. So you can just do another 2 and 5 and another 2 and 5. So now we're down to the very bottom, the prime numbers, which looks like it is 2, 2, 2. So we have 3 2s. 2 times 2 times 2 times, how many 5s do we have? We have 1, 2, 3. Times 5 times 5 times 5. Okay, so they want us to write it with exponents. So that's easy because we have 3 2's right here. So that's going to be 2 raised to the 3rd power times, and we have 3 5's. So it's going to be 5 raised to the 3rd power. And that's what they mean by grouping it and grouping the factors and then writing them with exponents. So 2 to the 3rd times 5 to the 3rd turns out that that's going to be 1,000 because that's what we started with here. Cool, huh? All right, that was easy. Let's do example 3 because you got this at this point, right? Yeah, you got it. We're going to simplify 100 minus 10 squared. So we're going to do the exponents first because the order of operations means that we do exponents first. They get first dibs when they're at the salad bar. So we're going to do exponents first. So let's just write this part the way it is, and then we'll write 10 squared. Instead of 10 squared, we'll do 10 times 10 because that's what it means. It means 2 tens multiplied by each other. Okay, so 10 times 10 is what? 100. So 100 minus 100 equals, easy peasy, right? That's a 0. 100 minus 100 is 0. So this whole thing simplifies to 0. Cool, huh? All right, guess what? You get even more in your lesson today. Even more. I know, you're probably looking exactly like this right now. We are going to learn how to write decimal numbers as fractions. This is part 2. So just a quick review. Here's your decimal right here. You've got a number before it, which is in the ones place. Then you have your decimal point right here. This first number past the decimal is in the tenths place. This second one is in the hundredths place with a TH at the end. This third one is in the thousandths place, right? Okay, we remember that. So that's basically, if you remember that, that's all you need to know to be able to change a decimal point into a fraction. Let's jump into an example. Put a smile on your face because here we go. Example 4. They want us to write 0.5 as a common fraction. Now, here's the decimal. We are one number past the decimal. So what is the units? It is in the tenths place because you're putting the 0.5 right there. 0.5, right? So it's the tenths place. Now, when you write it as a fraction, the tenths becomes the decimal because this is called 5/10. So the way you write that as a fraction is 5/10. And then all you have to do is simplify that. Just reduce it down and you are done. You have done the problem. That's it, right? Easy peasy. But what if it gets a little harder? Last one to the fields is rotten clams. This is the last example. So this is going to be the hardest example. Here we go. Let's do it. Write 3.75 as a mixed number. Now here we have the decimal and 2 numbers past the decimal. 2 numbers past the decimal. This is tenths, this is hundredths. So it's actually 3 and 75 hundredths. So it's 3 and 75 hundredths. Just like that. Now, we're not done because you can simplify that fraction, right? Righty-o, you sure can. So it's going to be 3 and 3/4. If you have any questions about that, let me know, okay, Addy? But that is basically it. That's it. Yes, that's it. And now you can go on and do your homework, okay? Have a great day, Addie. Love ya. Can't wait to see your homework. Bye.